Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at the cosine rule. Now you might be able to do the examples in this video already because you've most likely seen the cosine rule at GCSE before. I think it's on foundation and higher, so whatever you did at GCSE you probably saw the cosine rule, but we need to cover it in this lesson. So let's first of all start off with what can we use the cosine rule for. We can use the cosine rule for two things. I've got two triangles in front of me, and if you do a little bit of inspection, you can see this first triangle here has two sides that we know. Of course, triangle has three, but we know two of the sides. And then we have this side here that we don't know. We also have an angle. Okay, so we have two sides that we know. We've got AC here, and that's how we read a sign. We start off with one point and we finish with the other. This is the side AC, that's 19 centimetres. And then this side here, AB, is 12 centimetres. And we don't know the side of BC. We've got a question mark there, okay? We've got angle ABC, this angle here, angle ABC, is 64 degrees. So we have two sides and we have an angle. And we don't know this side, so in a question, what we would be expected to do is, if we were asked to use the cosine rule here, we'd want to work out this, the length of this side, BC. Okay, we'd want to work out the length of that side. If we look at this triangle here, we don't have any units on this triangle, but we do have three known sides. We have BC, which is 11, AC, which is 20, and AB, which is 18. And then we have an angle here that we've got a question mark. So if this was a worded question, you would probably be asked to work out the size of this angle. So the first triangle, we're being asked to work out the length of a side. And the second one, we're being asked to work out the size of an angle. So we can fill in the blanks here. The cosine rule is used to find a missing side or a missing angle. Okay, and if I put a little arrow, that is the missing angle triangle and that is the missing side. So those were just two examples, one of the missing side, one of the missing angle. There's two different formulas. They're different formulas, but actually they come from the same formula. You can get from one formula to the other just by starting with one formula, doing a little bit of manipulation to give you the other one. You've probably seen them before. The first one is the basic cosine rule, how we know the cosine rule to be. And it is under this box right here. If you are asked to work out the size of a missing, the length, we'll get there, the length of a missing side, you want to use this formula here. It's best to just remember the formula. It is given in a formula book, but it's best just to remember it so that you can just jot it down straight away. And it's actually quite easy to remember. It's a little bit like Pythagoras at the front here, but then we've got this minus 2bc cos A on the end. This is what you want to use to find the length of a missing side. There we go. We take a squared, which is one of the sides, and it's usually the side that is opposite the angle A. So if we were doing some labelling, this would be side A because it's opposite angle A. This here would be side B because it's opposite angle B. And then of course leaving this side to be C. And then all we do is we just take a squared and we say that's equal to the other side squared, so b squared, plus the third side squared, so c squared, and then minus 2bc cosine of angle A. So a squared is equal to b squared plus c squared minus 2bc cos A. That's what we want to use to work out the length of a missing side. We can do some rearranging on that to work out or make cos A the subject to then work out the size of a missing angle. And as you would expect, under that box there is the rearranged version of the cosine rule. This is what you want to use if you are working out a missing angle. So a missing angle, you need all three sides, just like this here, because if you could see in the formula, cos of A is equal to B squared plus C squared minus A squared. If we label the sides, this would be A, that would be B, and that would be C, because they're all opposite the correct angles. We need to know the sizes or the lengths of all three sides, because we need B, we need C, and we need A in our formula, and then we need over 2BC on the bottom. So that will give us cos of A, and then we can also take, we can find out A by taking the inverse cos of both sides. So those are the two formulas. Now, what you probably haven't done at GCSE before is looked at the proof of those formulas. And I just think it's nice to have a look at the proof of them so you know where they come from. So let's do that. We'll prove the side version, and then we'll just do the rearrangement to work out the angle version. So we can see here I've got a triangle, and I've got a nice triangle so that I can drop this perpendicular height down here. This perpendicular height goes from the angle C, okay, this point up here, all the way down to this horizontal side here. Okay, I've labelled this whole side C because it's opposite angle C, but then I've split it up from the perpendicular drop down, if you like, the perpendicular height of the triangle. This from A to here, this side is X, and then of course this little bit here is going to be C minus X, because the full side is C and that bit is X, so that bit there must be the full side minus this bit here, C minus X. The first thing I'm going to do is I'm going to treat the proof as kind of two separate parts, and I'm going to look at the triangle as two separate triangles. I'm going to look, oops, not at the rubber, I'm going to look at a highlighter, and I'm going to highlight that part of, oh, it doesn't work, okay, hang on a minute, let's do in green. This part of the triangle there, okay, looking at that triangle, and I'm just going to get rid of the fill, there we go, just looking at that part, we can see that that is a right-angled triangle, and the reason that's a right-angled triangle is because this bit here, that grey dashed line under there, is perpendicular. We've got a right angle there. So we've got a nice right angled triangle. So we know that we can use Pythagoras. So let's do that, okay? Let's do Pythagoras. Now, just ignore the second half of this line for the minute. Just consider this bit here. We've got h squared plus x squared is equal to b squared. That is just Pythagoras, but with different letters. H squared, this shorter side here, plus the other shorter side, which is x squared, is equal to the slanted side, or the hypotenuse, b squared. That is Pythagoras there. But also, we could look at the second triangle. Oops, I want to highlight, not that bit, hang on a minute. Let me see if I can move this out the way first. Oops. Okay, let's just do a bit of rearranging. Perfect, okay. I can also do this. I can consider that triangle there as well, that green part, which is the second half of the big triangle. And we can also do Pythagoras on that to give us this here. The two shorter sides, which is h and c minus x, square both of those and add them together. So h squared plus c minus x squared is equal to the slanted side, or the hypotenuse, which is a squared. So that's where this comes from here. On the next line, I'm going to kind of combine those two things together. We can see they both have an h squared in them. So we could rearrange to get h squared. I'll just do that here. H squared is equal to, and which way did we do it? We've done it, I think, this way. Let me have a look. Or would it be the other way? Let me just see what I've done here. So h squared is equal to a squared minus c, that should be minus c minus x squared. And then we've set those equal to each other. So we've rearranged just to get h on its own on each side, and then we've set these equal to each other, I think. The signs might be a little bit different, and you could also just take them away. So what I've done here is took this one away from this one to give us this equation here. So we have x squared minus c minus x all squared is equal to b squared minus a squared. I've just merged them together because they've both got the h squared in them. Hopefully you can see how I've done that. Right, the next line, I have then just expanded the bracket. I've kept this negative out here, so I've got x squared minus this bracket expanded, and then still the same thing on the right hand side. Then what I've done is I've distributed the negative over, and we can see that this x squared and this minus x squared will cancel. We'll then have minus 2cx, gives me a positive, and then minus cx squared, and then still the same thing on the right hand side. Right, then we get this, and we're aiming for the cosine rule here. So what we want is we want a squared at the front. We want a squared as our subject. So we've kind of got what looks a little bit like the cosine rule. So I'm going to add this a squared to this side and then get just a squared on the left on its own. So we have a squared is equal to b squared plus c squared, because we've added the c squared over here, and then minus 2cx over there. Now I'm going to call that equation 1 because I'm going to use that in a minute. That looks a lot like the cosine rule. If we look at what the cosine rule is, we've got the a squared, we've got the b squared and the c squared, we've got the minus 2, and what did we have here? Minus 2cx. We want minus 2bc cos a. So we don't want an x involved. Let's see what we can do in terms of x. We can actually come up with a different equation just using basic trigonometry. We can come up with an equation for x. X is this length here. It's this side from A to the perpendicular height of the triangle. Now let's just see if I can... No, it doesn't want me to. Okay, we'll leave that green bit in there. We can use trigonometry here to work out a formula for this side, basically. We've got a right angled triangle. We can work this side out, and we can say x is b times cos a. Why we can say that is because this is the side here, and we can work it out by looking at the hypotenuse, and we can say, let's say this was our angle, okay? This is our right angle, so if we labelled our sides, this would be A, this would be O, and that would be H, okay? We don't need the O, so I'm just doing some basic trigonometry. We've got A and H, so we need cos, so x would be equal to, and let me think here, A over H, cos A would be equal to A over H, so x over H, which of course is B. So then we would have x is equal to B cos A. So hopefully that basic trig makes some sense there, how we've got that here. And then all we can do is just replace that in this formula here. So we could call that formula 2, if you liked. I'll do that here actually. And then we can just combine. So in this step here, we've just combined them, both of those, to give me this. Oops. This here, okay? We've just done minus 2cx, which is minus 2bc cos a, okay? Minus 2bc cos a, which is what we've got here, okay? And then all we can do is just get rid of our brackets. Get rid of the brackets because you've done that replacement, and then just write it like in alphabetical order, basically, like the cosine rule. So a squared is equal to b squared plus c squared minus 2bc cos a. And that is the cosine rule as we know it for working out a side. Of course, we can then just rearrange to give us the version for an angle, and that's pretty much the proof, okay? So even if you don't understand that proof, you maybe struggle a little bit on how to get this trigonometry here. It's just basic trigonometry, but it just gives you an idea that this formula is not just plucked out of thin air. At GCSE, you might have just been given it and you've used it. Do that at A-level, but also know the background of where it comes from as well, because it's actually quite interesting and it makes a lot of sense when you actually look at it in terms of the big triangle, splitting it up into two, and just doing basic substitution and basic trigonometry and Pythagoras. Okay, let's have a look at an example. So, like I said at the start, you might actually be able to do these examples from your GCSE knowledge. So, use the formula, calculate the length of side AB, which is this side here. We know we can do that. We don't know how we can do it, But we know that we can because we're being asked to do that in the question. And because this lesson is on the cosine rule, I would use the cosine rule. You have a side, you have another side, and you have this angle between them. So that's what you need to work out a side. You need the side, the other side, and the angle between them. That will allow you to work out this side. So side, angle between them, which I can't highlight for some reason, and then the other angle, okay, that is what you need. So you are able to work out that side using the cosine rule. So pause and have a go, press play, and then we'll work through the answer. The first thing I would do is I would write down the cosine rule. So let's do that here. And the more you practice these, the better you'll get at just writing down the formula. A squared is equal to b squared plus c squared minus 2bc cos a. Now, the more you actually do this, you'll realise that a, b and c doesn't always match up to the side you're trying to find. Really, this side here, if we were to label it properly, that would be A, this would be B, and that would be C, because they're always opposite the angles, okay? But if you actually have a look, we have A squared as our subject. It doesn't matter. This is not your A. These are just your two sides that you know. So really, these two sides are actually B and C. We're trying to find A. So you can think about it like this. You can think, I've got this side A squared that I'm trying to find, so this is A, if you like. You could also call it X. You could say X squared is equal to this here, okay? But that's side A, and then B and C are just the sides that you know. And then cos A, well, that's the angle, and the only angle that we know is this angle here of 100 degrees. So it's just a game of substitution. Let's substitute in, so A squared, which we could actually say AB squared if you liked, actually. Maybe that might be better. Let's do that. AB squared, which is the side we are trying to find, is equal to the other two sides that we know squared and added together. So 6.5 squared plus 8.7 squared minus 2 times B, which is the first side that we had here, which is 6.5. times the second, which is 8.7, times cos of angle A. Now, the sides, again, don't add up, so this is actually angle C, but it doesn't matter. It's the only angle that we know, and that's what we're trying to use. So that must be cos of 100 degrees. If you're using a calculator, make sure your calculator has a little D letter at the top. If it has an R for radians, which you'll learn later at A level, then your calculator will give you an incorrect answer. So make sure it's got a D letter at the top, okay? Then if you substitute that into your calculator, I'm going to look for the answer here. It's going to give you this, okay? You're going to get AB squared is equal to, and let me just have a look, 137.57, and that carries on. We don't need too much of the answer there. Now, that gives me AB squared. I don't want AB squared, I want the length of AB. Okay, that was in the question, the length of the side AB. The side is not AB squared, so we just need to do one more step. We just need to square root. Don't forget that when you're doing these questions. That's not your answer, you need to square root both sides. So AB will then be equal to the square root of 137, whatever, 0.75, etc. And that gives you this. It gives you 11.729. And then ... more comes after that. But I'd always give your answer to 3 significant figures. That's what we generally do if we have not been specified what to give our answer to. So I'll just say this, I'll do a little arrow. So AB is equal to 11.7. That is it to 3 significant figures. We've got 1, 2, 3. The 2 just leaves the 7 as it is. And of course, don't forget your units. The other lengths were in centimetres, so the length that we've just found will also be in centimetres. And that is the length of side AB. Hopefully not too tricky. Let's have a look at another example, and then we've got one more at the end. Okay, example 2 says find the size of the smallest angle in triangle ABC. How do we know what the smallest angle is? I'll give you a hint. It's opposite the smallest side. So just use the formula for the angle cosine, the formula that makes that finds the missing angle. Got my words twisted up there. Use that and then have a go. Just do a game of substitution and make sure to take the inverse cos of both sides. You'll have cos A equals something. We don't want cos A, we want A on its own. So take the inverse cos of both sides. Pause and have a go, see where you can get up to, and then press play and we'll work through the answer. Just like we started that first example, I'm going to write down the formula, and it's this. Cos of A is equal to B squared plus C squared minus A squared divided by 2BC. And the more you do, the easier that will become to practice. Even though the letters may not add up, which they don't, we're trying to find the smallest angle. So like I said, it's opposite the smallest side, so it must be this angle here, okay? Because this is our smallest side of 3 centimetres, so it must be opposite there, so it's this angle here. Even though the letters don't add up, really what it is it's this, okay? B squared, so we're trying to find cos A, so this would be side A. It's the other two sides minus the side that's opposite the angle divided by 2 times the other two sides, okay? Really what our formula is here is cos C is equal to B squared plus A squared minus C squared divided by 2AB. Okay, if we ignore this one for the minute, because that's our general formula, if we switch over the letters for A, B and C in our triangle, this is what we're substituting. This is side C. I'll do it in green. This is side C, this is side A, and that's side B. So if you wanted to, you could basically substitute like that. Or you could just think, these are the other two sides that are not opposite the angle I'm trying to find. Then we take away the side that is opposite the angle and we divide it by 2 times BC. We've already worked out what BC is. But let's follow it like this, okay? So cos of angle C is going to be B squared, which is 6 squared, plus A squared, which is 5 squared. Those are the sides that are not opposite the angle we're trying to find. Then we're going to take away the side that is opposite the angle, so minus 3 squared. Divide that by 2 times, and then really it's those two multiplied together, the sides that are not opposite the angle. Okay, I'm going to take this again from the book, and when you do that, you get this. You get cos C is equal to 0.8666, and maybe that's recurring, it just carries on. Then, here is where we take the inverse cos of both sides, and hopefully you know what that is from trigonometry at GCSE. I can then just say C is equal to cos to the minus 1. That's not a power of minus 1, that's just how we write it. Cos minus 1 is inverse cos of the answer on the right hand side, so 8.666, that carries on. Which then tells me that C, when you put that into your calculator, if it's in degrees mode, there should be a D at the top, 29.9 degrees, and I'm just going to write 3 significant figures. Again, give your answer to 3 significant figures. And if you actually have a look at the triangle, that kind of makes sense. This angle here, if we look at it, if this was sort of our protractor line going up here, it looks about right to be about 29 degrees. So our answer is correct there. The final example involves some algebra, so don't be put off. We're just being asked to find the value of x. We have a triangle, we have 3 sides, but we only know one of the sides. This side here, AC, is 5 centimetres. This side is x plus 2 centimetres. This side is x centimetres. This angle here is 60 degrees. So really, all we can do is, because x is a side, all we can do is use the formula that finds a missing side, right? So let's write that down. Let's just do that before I hand over to you to have a go. A squared is equal to b squared plus c squared minus 2bc. Okay, again, the a and the b and the c in this, oh sorry, I've missed the cos a. Again, the a, b and c and then the capital A for our angle, they may not add up or match to the a, b and the c in our triangle here. Just make sure you get them the right way round. So we're trying to find the value of x, and x is involved in this side here and in this side here, and we know the angle between them. If we do that, if we were to work out the side of AC, we would be using this side, and the angle between them. So kind of imagine that we don't know the length of this side here and work it out. That will give you a formula with the x. Then imagine that you don't know it, so we don't know the side of that 5, okay? But then we actually do, so you could substitute the 5 back in, and then you should be able to work out the value of x. That may not have helped too much, but just think about what you have a go, press play, and then I'll work through the answer. Okay, let's do a little bit of substitution. So, like I just said, let's imagine we don't know that 5. We don't know the length of AC. What we want to work out is the length of AC. Let's imagine we don't know it and let's work it out. So, AC squared, okay, is going to be the other two sides squared and added together. So b squared, doesn't really matter which one I call b. In our triangle here, it's actually this side that's b. But the formula is just the other two sides that we know. We don't know them, but we know them in terms of x. So let's use them in terms of x. We'll have x squared, and we'll have plus the other side, x plus 2 squared, minus 2 times b times c. Those are the two sides that we're not trying to find. So x plus 2 times the cosine of a. Now, again, the cosine of a is this angle up here. We're actually using cos b because we're using this angle here. But don't worry about that. Just use, when you're trying to find a missing side, which, for example, it's this one here, it's the other two sides added together and squared, minus 2 times these two sides multiplied together times the cosine of the angle between them, cos 60, and that's 60 degrees. Okay, let's just do a little bit of manipulation on that. So we're going to get this, we're going to get x squared plus 2 plus x squared, we'll leave it like that, minus 2 times x, and I'm just seeing what they've done here, they've just simplified it like this, 2 times x, x plus 2, cos of 60. Now you should know what cos of 60 is, so let's also make that a little bit simple. Okay, x squared plus, we've got another x squared, so x squared plus, that's going to give me 4x plus 2, I believe. Yes, 4x plus, sorry, 4, minus 2x squared minus 4x, all multiplied by cos 60 on that bit. So let me do that again, actually. Let's see how we can do that. Sorry, minus, it's going to be 2x squared plus 4x, that's better, times cos 60. I've just expanded that bracket there and left the negative out the front. Okay, then we can do a little bit of manipulation or sort of collecting like terms together. I have 2x squared at the front here, so 2x squared plus 4x plus 4. We know what cos 60 is, and I'm just looking here in the book. If you know your trig values, you should know cos 60. Cos 60, and you can put it in a calculator if you don't know it, is actually a half. So we can replace that with a half. And I'm going to put it out the front here. I'm going to have minus a half times 2x squared plus 4x. Okay, remember this is AC squared all the way down here. So AC squared is equal to 2x squared plus 4x plus 4 minus x squared minus 2x. Then I can do a little bit of simplification here. And this is what we're going to get. That will cancel just that 2 with that one there. We've got 2x squared minus x squared. 4x minus 2x will give me 2x and then the plus 4. So let's write that down. We'll have x squared plus 2x plus 4. So in terms of x, that's what AC squared is. Now, we know, if we go back to the triangle, what the length of AC actually is. We just imagine we didn't know it, and we just did the cosine rule to work it out. These two sides and the angle between them will allow us to work out this side. But let's substitute now AC into this formula for the side, if you like, there. So we know that AC is equal to 5 centimetres. So therefore that tells me AC squared is going to be 25 centimetres, just square both sides. So AC squared will be 25, so we'll have 25 is equal to x squared plus 2x plus 4. Okay, just by substituting into this side, or this equation here. Okay, so then I can basically just solve this like a quadratic. I can take off 25 from both sides to give me this. X squared plus 2x minus 21 is equal to 0. And the reason I want to solve it like a quadratic is because I want to work out the value of x. That was the original question, find the value of x. So we're very, very nearly there. Now, this does not factorise, so if you were to put it in your calculator and solve it, it would give you as a surd. If you were to do the quadratic formula, it would give you it as a surd. Just solve it as you would usually with a normal quadratic, whatever method you like. Complete the square on it if you want to, but I'm just going to take the answer. Hopefully by now you can solve that quadratic. So when you do the solving, you get x is equal to minus 2 plus or minus the square root of 88 divided by 2, okay? And then that's going to give you 2 answers, but we're only going to take one answer, actually. And the only answer we're going to take is the positive value of x. So because x is a side, x has to be greater than 0. So we're only going to take the positive version of that, okay? And so, when you put that into your calculator for the positive version, x is equal to 3.69, and is it centimetres? Yes it is. 3.69 centimetres to 3 significant figures. And that is your final answer for x.